Hello everybody, good day today. We will discuss structure function. The topic is system safety quantification by structure function approach. So, we will discuss the basic of structure function and then several examples I will put forth, so that you will understand the structure function approach. And the lecture is prepared from the book Probabilistic Risk Assessment and Management for Engineer and Scientist, Kumamoto and Henley. So, what is structure function? So far what have you seen? You have seen fault tree and event tree, and then in fault tree cut sets. Then we have shown you different quantification in terms of basic events, and then we started the system safety quantification, where we have defined that the system is available if the top event does not exist, top event in the fault tree. So, then we have shown you that how to compute the system safety, particularly from fault tree quantification point of view, where the top every fault tree has a top event, and then probability of top event, if it is a failure event, then that is the unavailability of the system, and if the top event is a success event, that will ultimately tells you the availability of the system. And we also consider one top event at a time, not several top events. Then we have seen that how reliability block diagram can be used for quantification, and we have seen that there are several methods for quantification. One of the methods is structure functions, another one RBD, reliability block diagram, we already given to you. Another one is the truth table, that is also you have seen in my last lecture. So, today our discussion will be on use of structure function in quantifying the system safety, particularly in terms of fault tree or success tree. When you go for cut set, we say fault tree. When you go for path set, we basically talk about the that is the success tree. And today I will discuss that how the structure function will be defined, and it will be used with several examples. So, essentially what is the definition of structure function? You have seen in any fault tree there is a top event, and then there will be several bottom events. So, suppose if we say this is B1 and this is B2 in this manner, this is Bn, there are n number of bottom events or basic events. We started thinking I equal to that 1 to n. Okay, so that means n number of basic event. So, then the Bi is basically the ith basic event. So, we will relate a variable called yi with reference to Bi, the basic event I, in such a manner that these relations hold. What is the relation here? Yi equal to 1 if the basic event exists. So, suppose this is basic event B1. So, B1 either it is unavailable or available, or unavailable means it is failed or it is working. So, now basic event exists means we are defining basic event, let the failure of that particular component, or that is what is the basic event, and then basic event exists means this particular ith component is at fail state, or 0 when the basic event does not exist means ith component is working. So, but if you think that you will be use other way around, that it is success or failure, that 0 and 1, so that is also possible, but for in terms of fault tree we have defined the basic event as failure event. Okay. So, now if I say yi is basically 1 or 0 depending on the basic event exist or does not exist, and in the fault tree format all those basic events basically leading to the top event. So, we will create another function for top event which is indicator variable psi y. So, that is what is the psi indicator variable psi y? Psi y talks about the top event point of view. So, top event if it exists, then it is 1, if top event does not exist it is 0. So, then essentially what happened in structure function, you have defined two indicator variables, two types of indicator variables, one for basic event, another one for top event. Now, for basic event the indicator variable is yi, it takes value of 1 if the ith basic event exists, otherwise it takes the value 0, and similarly psi y is another indicator variable which takes value of 1 if the top event exists, otherwise 0. Okay. So, this is what is basically the definition. Now, our sole purpose is that psi y the top event will be a function of basic events. So, y1, y2, yn function of basic events. So, this is what is our structure function. So, that means psi y is a function of that top event indicator variable is a function of basic event indicator variable, that is our function. Now, using this we will be able to find out the system unavailability, availability, and that is what is the primary concern in case of computation, system safety computation. Okay. Now, you require little bit of that Boolean algebra and event Boolean form and algebraic operations, that knowledge you require. We say Bi is basically the basic event, ith basic event, and in terms of Boolean, suppose basic event exists means yi equal to 1, and in algebraic form also we write yi equal to 1, that means note is that remark is that event I exist. When you write Bi bar, we have seen earlier, so that means event does not exist. So, yi is 0 and in algebraic form yi also 0. So, event does not exist. Now, when we talk about intersection Bi intersection Bj, this is basically then we are basically talking about that yi intersection Ej equal to 1, that means that intersection exists kind of things. Similarly, union, that also in Boolean we are writing that is 1, and when there are n number of basic events, so n this n indicator variable will be interacting, so that interaction is 1, and when it is union, that union is also 1. Okay. Now, in algebraic form what we are doing, the symbol you are what you are writing in Boolean you are writing intersection in this manner, union in this manner, in this symbol, but when you are writing in algebraic form for intersection it is basically multiplication yi yj, but when it is union form, that is important. So, yi union yj equal to 1, it means in case algebraic form this is the issue. Okay. So, please understand this is my yi union yj equal to 1 in Boolean, but in algebraic form is this. So, 1 minus yi and 1 minus yj. Okay. So, when you are writing again interaction, you see that you are just multiplying. Then when there are n number of items, you see that here 1 minus yi and 1 minus yj multiplied. So, here n times this will be multiplied 1 minus this, and how it is happening that you also know, because earlier we have discussed similar things. Then what is the actual physical meaning is that, so from probability point of view, when we use indicator variable, then the probability value, suppose probability Bi intersection Bj is nothing but expected value of yi intersection yj. Similarly, for union case expected value of this Similarly, when there are n number of item interacting this or union of this. So, okay. So, this is what is basically you have to understand that when you are writing events, then you are writing either intersection in this manner, union in this symbol. When you are writing in terms of Boolean, intersection this, union this, and when you are writing in terms of algebraic form, then you are using for intersection all indicator variable are multiplied, but when there is union, then you are writing first finding out that complementary of this 1 minus that 1 minus y I, and then multiplying all those things, and then finally, all that multiplied terms complete term is subtracted from 1. Okay. So, this is the way of representation for the different kind of situations. Okay. So, please keep in mind. Now, with this simple the representation, then we will go to the next slide, where our aim is basically that we will show you that in case of AND gate and OR gate, how this structure function works. I already told you that probability of y I equal to 1, that is nothing but probability that if bi event bi exists, this is nothing but expected value of y I, where y is a indicator variable. Now, then what will be the probability of top event, which is basically system unavailability? Then it will be probability that psi I equal to 1, which is the top event indicator variable, and that is nothing but expected value of psi y, and this is nothing but sum of psi y and probability y. So, this is another important expression for you. So, what you have done here, you have created y I indicator variable. So, you are considering all y I, and then you have also created indicator variable for the top event. So, then ultimately what happened, you are basically finding out that multiplication of psi y and probability of that y, and then summing that all for all the events all y, that is why. And this is what is our formulation, Boolean form and algebraic formulation we have given you. So, with these two, first we will apply this table and see what happened to how do you compute psi y, and then using this expected value we will show you how you will compute the unavailability. So, let me tell you, or you all know that as it is AND gate, so psi y is a function of psi y1 to yn. It is basically this top event is a function of all the basic events. Now, this one, because of AND gate, we can, if you use Boolean, you can write like this. You see, because of AND gate is this one. So, what you are writing, this you are writing. So, this is nothing but intersection I equal to 1 to n y I, which is this. So, we are writing like this. Then this one, if you write in terms of algebraic form, so y1 to yn, you see the same way you are writing. Now, then what is the unavailability? Unavailability QST is expected value of psi y. So, you are writing expected value of psi y here. Now, expected value of psi y means expected value of y1 into y2 up to yn. As y1, y2, yn are the basic event indicator variable. So, they and they are independent. So, their expected value of joint will be actually expected value will be individual expected values multiplied. So, expected value of the multiplication of all the indicator variables will be equal to that expected values of each of the variables, and then multiply the same. Okay. Now, if your gate is OR gate, this one was AND gate. Gate is OR gate. So, what will happen? You see, this is the Boolean form. So, you are first writing in the Boolean form, and then if you want to write algebraic form, so algebraic form is this. So, 1 minus I equal to 1 to n, 1 minus y I, that is what we have written 1 minus y 1, 1 minus y 2, like 1 minus y n. Then QST will be expected value of this, means expected value of the entire term, and then expected value of 1 is 1. Now, expected value of all those things as y 1 to y n are independent, then 1 minus y 1 to and 1 minus y 2, they are also independent. So, as a result, you are what you are doing expected value, you are multiplying expected each of the expected values. Now, again you can enter this into the expected values into the bracket. So, expected value of 1 is 1 and then minus expected value of y 1. So, this is the form. Okay. So, wherever you get AND gate, expected value, you will basically multiply the terms and expected value will be expected value of multiplication of all the indicator variables. And whenever you are having OR gate, this is the algebraic expression for OR gate, this one, and then this is the expected value or QST. So, okay. So, this is basically just representation in terms of basic event and the top event given different logic gates. And we may go for a little complicated tree now, and then let us see what will happen there. So, now instead of just one or AND gate, we have here little complex, simple in the sense complex in terms of the earlier trees what I have shown you here. So, now what happened here, we have one AND gate and one OR gate, and there are three basic event A, B, C. So, what will be the structure function psi y? So, this AND gate is there. So, intersection we are using. Now, this quantity you require to find out. So, this quantity is nothing but because of OR gate. So, YB and YC. So, what is YA, YB, YC? YA is indicator variable for this one if A exists, otherwise 0. YB is indicator variable 1 0 and YC is again indicator variable 1 0. If it exists, it is 1, otherwise not. So, then if I want to find out with this OR gate, you have earlier seen the inputs will be union, and for AND gate it is intersection. So, your structure function in terms of Boolean you are writing like this. Now, you can write in terms of algebraic form. So, first you write algebraic form of this intersection the 1 minus YB and 1 minus YC, and this is for this. Now, intersection is there. So, YA multiplied by this. So, now if you just simplify this one, doing some more algebra. So, you will be finally getting this equation. So, YA YB plus YA YC plus YA YB YC. Okay. So, that means this is my structure function for this kind of fault tree. And then unavailability will be expected value of, so QST is expected value of this. So, expected value of YA YB, expected value of YA YC, expected value of YA YB YC, these three. This will be summed up and this will be added and this will be subtracted. So, now YA YB again because of independent nature, that will be multiplied and this. So, this is your structure function for this fault tree. Now, we will see that another real example which I have already given you in last class, There we have said this is basically stale gauge quench and clean up system. There are several components and there are three objectives. First one is that your reduction of temperature, then your basically quench that through quenching, then your basically moisturization, and finally particles to be removed. So, all those things combined together, we have seen the fault tree earlier. This is our fault tree. Okay. So, what is required? You require to find out the structure function of this. So, given this fault tree or given this system, you have to develop the fault tree, and then from the fault tree you find out the structure function, and once you have the structure function, find out the unavailability part. Okay. So, let us see, yes, this one. So, this fault tree you have seen in my last class. Now, what is happening here? This is an OR gate. So, YA, this, suppose if I say this is my G1 gate, okay, this is G gate, this is G1 and this is G2 gate. So, that means this union G1 and union this and union this. Okay, this is G. So, let this one is another gate, suppose L gate, let it be, forget about this. Okay. So, then what happened here? We have written one structure function for this small one, another structure small one here, which we have defined here. So, that means in this tree what happened, apart from this OR gate, there are this is basically the tree has two AND gates, this and this. First we have found out the structure function for these two AND gates. So, psi 1 and psi 2, these are this one. So, if I know psi 1 and psi 2, then A, B, A, D and G, another basic events are known. Using this OR gate, you can find out the Boolean part like this. So, this, all union. Now, when union is there, so this will be 1 minus all union, 1 minus this, 1 minus psi 1 y, 1 minus d, 1 minus psi 2 y and 1 minus y g. Okay, so, this is the formula you have seen earlier. Now, then 1 minus y a, now this one 1 minus psi 1 y, this structure function, its value is y b y c, we put here. Similarly, other one is y e y f, we put here. So, this is my structure function, psi y equal to this. Then for QST, what you will do? QST is the expected value of this. So, expected value of this, once you put, finally you will end up into this equation. So, with this example, we have shown that how the structure function will be used in some real cases. Okay. Now, let us see another example, gas oven system. Here you see there are many basic events. So, what we will do, let us write. Suppose this is y a, indicator variable, for this y b, for this y c, for this again y b, because this is basically valve open, this is valve open. Now, this one y e and this is y f. So, that means y a equal to 1 means rupture takes place, 0 means no rupture. Similarly, y f equal to 1 means valve C open, otherwise 0. Now, we want to find out the structure function for this. So, if you start from this top event, that you want to find out the psi y here, and because of OR gate, and you have to first find out that how many inputs are there, first inputs, second inputs and third inputs. So, if that means what you will do, your psi y here equal to that first input, this because of OR gate union second input, again union third input. Okay. So, very easily you see the first input is yi, ya, so you write this one, then union you are writing. What is the second input? Second input is a AND gate with two event yb and yc, two indicator variables or b and c events. Because of AND gate, you use intersection. So, that means this is yb intersection yc. Then again your union is there, but for the third inputs you see so many things are there. So, what you do for the third input, you start from the bottom, then here OR gate, so ye and yf. So, with OR gate we can write ye union yf. So, this is now here what happened, it is AND gate. So, with inputs this and this, so this is our yd. So, we can write for this ye union yf because of AND gate intersection yd. Further again here is another AND gate. So, that entirety for the third input will be again intersection yb. So, what you are writing, that's why you are writing ye union yf intersection yd, then again intersection yb, this one. So, then ya you see ya union yb yc intersection, then union this portion ye union yf intersection yd intersection yb. Okay. So, this is our structure function. So, once you know the structure function, then you know how the expected value to be computed. So, what will be the case? Expected value of this, suppose if I go for the algebraic form, I have not written the algebraic form here and then gone for expected value. So, algebraic form is this one in between what is given here. So, because of union, so what you are writing 1 minus, then what is the first term ya, so 1 minus ya, product second one. So, 1 minus yb yc because of this intersection formula. So, this part is over. So, this one taking care of this one taking care of this. Now, third intersection here in between again union and intersection is there for third union. So, for this one we are writing minus we are taking care of inside. It is basically for the first one is this 1 minus ye into 1 minus yf. Then this intersection this, so multiplied by this, again intersection if this multiplied by this, so 1 minus this whole, that is the algebraic form. Now, when you are finding out QST, you are taking expected value of this algebraic form. So, you are writing like this. Okay. And then as the expected values are nothing but the probability values. So, when you put all those things, finally you are getting QST is 0.001. So, another example here, Pisat tank rupture. This fault tree you have seen earlier, and in the same manner we have basically found out the first you find out the structure function. Structure function is this one. So, how many events? 6 different events are there. So, put the structure function values. So, this is basically OR gate with 2 inputs. So, that is YB1 and entire this one as inputs. So, now this one is an AND gate with 2 OR inputs. So, that means that in 2 OR inputs we have written like this, and finally, we have we have basically integrated all those things and we got this structure function. Okay. So, I hope you will be able to develop this structure function, because the similar way earlier I have shown you. Then QST, you have to take the expected values. Okay. Now, let us see that if we put the basic event probability values, then using and use get by get method find out the top event probability, and using structure function find the top event probability, is it matching or not. You see, using get by get method, when we computed, we found this. Now, using structure function, expected value is the probability value, we are also finding out the same probability. So, it will match when it is a small fault tree, similar kind of fault tree, you can develop and compare the things, but for large fault tree it will be actually you should go for programs. Then I will show you another interesting one. Here little difference you will get. The difference not in terms of that example point of view, but use of expected value point of view, that when you should use the expected value, should you use in between without decomposing the structure function into the lowest possible level, or in between if you use expected value, what are the problem you will encounter. So, here you see it is a voting gate case, and for this voting gate case you can very easily define the structure function. And now, the structure, once you know the algebraic form, the structure function is known, then QST you can use the expected value, and in this manner if you use the expected value of this, then put expected value inside and then finally calculate the QST, then you are getting QST value 0.246. So, here what happened, actually the problem we will see later, but here you please understand that the product, there are the product terms 1 minus y1 y2, 1 minus y2 y3 and 1 minus y3 y1. So, there are 3 product terms. So, y1 this one and this one, where at least in 2 of the terms each of the indicator variables appearing. So, even though y1, y2, y3 or the basic events are independent here, but the product term 1 minus this and 1 minus this, they are not independent, because they have the common variables, indicator variables. So, now if you use QST expected value here inside, then you are basically committing a mistake, and that mistake is explained here. What is this? Instead of putting expected value earlier, if you further decompose this, and you will find out interesting thing is that in the first term y2 y2, in the second term y3 y3, third term y1 y1, and the fourth one y2 y2, y1 1, y3 y3. As y1 is 1 when the event exists, then y1 multiplied y1, it is actually 1. So, as a result, in Boolean case, so you have to write this y1 y2 y3 and y1 y2 like this. So, you have to write like this. Okay. So, 1 minus 1 cancel out, y1 y2 y1 y2 y2 y3 y2 y3 y3 y1, and this one when you use this concept and then you find out that this has been basically reduced to minus 2 y1 y2 y3. So, now if you put expected value here, that means you are basically using 0.3 and multiplying there. Here 2 times you are multiplying 0.3. So, it is not 1 into 1 is 1, it is 0.3 into 0.3 is 0.09. So, it is making the problem, creating the problem. So, that is why what happened, when the product terms they are not independent, ultimately if you use expected value formula earlier without decomposing the structure function to the lowest possible level, you will commit mistake. And now what happened, after decomposing to this level, when we are calculating QST, that is unavailability, using the expected value, then we are getting this value 0.216. So, we have written why this is happening, because dependent product terms as each indicator variables appear more than once in the product. I have already told you. Please be careful for this kind of fault tree when you are using structure function and then the expected values you are using. So, you should use the expected value at the lowest possible level, not at in between. Okay. So, thank you very much. I hope that you have understood. Good day. Thank you.